Here we want to find the derivative of this function by implicit differentiation. So the first thing we're going to do is take the derivative with respect to x of the left side of the equation, which is 2x cubed plus x squared y minus xy cubed, and that's equal to the derivative with respect to x of the constant 3. Okay, so when we take the derivative of the first term, 2x cubed, we end up getting 6x squared. Plus, now we have a product here, so we need to take the product rule of the derivative. So we take the first function, which is x squared, and then multiply it by the derivative of the second function, and that's going to be times y prime, since it is the implicit differentiation. And then plus, we're going to take the derivative of the first, which is x squared, times y. Okay, then we have minus, so this, and there's another product rule here. So we have minus the first, which is x, times the derivative of the second, which is y cubed, and then times, again, since it's an implicit differentiation, this is y prime, plus, okay, so since this is minus, so we have this entire thing, minus is plus the derivative of the first times the second, which is y cubed. And that's going to equal the derivative of 3, which is 0. So in step 3, let's find a derivative. So we have 6x squared plus the derivative of y is going to be 1. So 1 times x squared is going to give us x squared y prime, plus the derivative of x squared is going to give us 2x times y. And recall here, we're going to have to distribute the sign to both of these terms. So we're going to get minus x times the derivative of y cubed is 3y squared times y prime, minus, since we're distributing the minus sign, the derivative of x is 1 times y cubed, which is equal to 0. So let's go ahead here. So let's combine all the y primes together on one side. So we have x squared y prime minus, that should be 3x y squared times y prime, plus 6x squared minus y cubed plus 2xy, and that's equal to 0. So what we're going to do is we're going to isolate all the y primes on one side and everything else on the other side of the equation. So we end up getting the following. We have x squared y prime minus 3x y squared y prime, and then that's going to equal negative 6x squared plus y cubed minus 2xy. Now again, we want to be able to solve for y prime, so we're going to factor that out. So if we factor out y prime, then we end up with x squared minus 3xy squared, and that's equal to negative 6x squared plus y cubed minus 2xy. And now in order to solve for y prime, we're going to divide both sides by x squared minus 3xy squared. So we get x squared minus 3xy squared. So y prime is going to equal negative 6x squared plus y cubed minus 2xy divided by x squared minus 3xy squared. And therefore that is the derivative using implicit differentiation.